Give condensed and bond line structural formulas and identify the functional groups present, if any, for A, B, and C. Wow, what is this? Let's take a look. We are supposed to write down bond line and condensed structural formulas. What is bond line formula? What is condensed structural formula? Well, see, one long or expanded form is you write down every carbon, every hydrogen, H, H, H. Then it's carbon and then again carbons. You go on writing it. That's very expanded or detailed formula. Condensed form would be when you don't make such a hue and cry about this. And bond line notation is very simple. What do you do in bond line notation? You simply make lines, straight line. One carbon-carbon bond is represented by a straight line. Hydrogens disappear. We assume that whatever are the remaining valencies, they will be specified by hydrogens. Every carbon is a corner. Every corner is a carbon. That's it. Heteroatoms like nitrogen, oxygen, etc. are clearly mentioned. Every corner is carbon, and hydrogens, as per requirement, just for satisfying valencies, we assume that students of chemistry at least know how many hydrogens would be there. They just eat it away. That sounds odd. We'll explain you. I'll give you more examples just to make you more comfortable with that. But first, let's do these. 2,2,4-trimethyl pentane. Now, 2,2,4-trimethyl pentane or anything you want to draw, see, bond line is the simplest. First, we'll start with the word root, pent or ane. So, we need 5 carbons. 1, 2, 3, 4, 5. Every corner is a carbon. That is the concept of bond line. And then we have 1, 2, 3, 4, 5. For your convenience, I have numbered this. Otherwise, numbering is not necessary. 2, 2, 4. So, you have 2 methyl groups and 1 methyl here. This is the bond line notation for 2,2,4-trimethyl pentane. Right. What else? We also wanted condensed formula. What is condensed formula? I'll just write it and show you. Like I have CH3 groups, right? This is CH3, this is CH3, this is CH3, and this is one carbon. Now, how do we write this in condensed formula? We say it is CH3 whole thrice carbon. CH3 whole thrice carbon. Now, this is attached to CH2. C, then you have CH2. And then we have, this is CH. So, we have CH. Now, whenever there is a side chain, in condensed formula, we simply put a bracket. It is CH3, CH, this is CH3 whole twice. CH3, CH3. This is how we write it. This is the condensed formula, and it earlier was bond line notation. Of course, now it is no longer. But then if you want to make it bond line, I can help you out here. I'll just erase the names. I'll just do it again only. That's much simpler. That would be the bond line notation. This is bond line. I draw one here, one there. It doesn't matter. Anywhere you want. A is done. Now B. Such a long name. It's okay. Let's look at the end. It is propane. Then we have tricarboxylic acid. At least we get propane. If we get propane, so we understand that there has to be a carbon chain of 3 carbon atoms. That would be, well, 1, 2, 3. 1, 2, 3 carbon atoms. Lovely. Now, I have 1, 2, 3 propane tricarboxylic acid. That means I have 3 COOH groups attached to it. So, I will take COOH, COOH and COOH. Oh wow. And I have 2 hydroxy. So, if this was 1, this is 2, this is 3. So, 2 also has OH. Fascinating. So, what is this? Is this bond line notation? Not exactly, but I've just written this, just for my reference. Now, I'll just write down the condensed and bond line both. We'll start with condensed. Fine. We have a COH group. So, we have a COOH group. And this is attached to 1. 1 is how much? CH2. So COOH being attached to CH2. To COOH, then we have CH2. And then now we have only one carbon C which is attached to OH and COOH. COH, COOH. Side chains are written in brackets. Simply that is condensed formula. And then we have another CH2 which is CO, which is again attached to COH. So we have COH, CH2 one carbon, then second carbon which is attached again to OH and COH. Since they are side chains, they are just put in round brackets one after the other, and then we have CH2COH. This is the condensed formula. What about the bond line notation? This can be slightly improved, and I will get the bond line notation also. How exactly? Let me do it for you. Now this is COOH. This is COOH. This is OH, which is fine, and this is COOH, right? In bond line notation, the care is we are not explicitly writing down carbons. This is not a bond line notation, strictly speaking, because I have explicitly mentioned carbon atoms. So just to make it more pure, I just improved it like this. This was just for my rough work and reference. I'm just erasing it out. That's it. And this is old questions. I'm again removing it. This was second part. Third one. Third is the easiest. Hexanedial. Oh my God. What does it say? What is hexanedial? Let's see. Hexane means 6 carbons. 1, 2, 3, 4, 5, 6. Dial. It is double aldehyde. Aldehyde is only at the end. Oh wow, 1, 2, 3, 4, 5, 6. Is this hexanedial? It is. This is the bond line notation. Fascinating. And what about the condensed formula? We could also write it. It is CHO. That is aldehydic group. Fine. And then you have CH2. CH2. If you want, you could write it 1, 2, 3, 4. 4 times and CHO like this. If you are more enthusiastic, you can go on repeating CH2s. That is not advisable. Just write it like this. This is the condensed formula.